The following past paper question reads that an aqueous solution was prepared. An aqueous solution was prepared containing 1 mole of silver nitrate. So if you have 1 mole of silver nitrate initially, silver nitrate contains silver ions, and it's an aqueous solution, so it's 1 mole of aqueous silver ions and 1 mole of FeSO4. So an aqueous solution was prepared. FeSO4 has Fe2 plus ions in it. So that's the initial concentration of silver ions in Fe2 plus in the solution, and it's a 1 dm cube solution, so the concentration would be 1 mole per decimeter cube. So your initial concentration is given. And when equilibrium was established, there was 0.44 moles of silver ions in the mixture. So again, at the end of the reaction, there are 0.44 moles of silver ions in the mixture. So I've copied this equation over here, and I'm going to do my working on this equation over here. So first, the initial concentration. Initial concentration of silver ions is 1 mole. Of Fe2 plus is also 1 mole per decimeter cube, because it's a 1 dm cube solution in total, so it's going to be 1 mole per decimeter cube. That's the initial concentration, and the product is the 0 moles of silver solid and 0 moles of Fe3 plus, because initially he didn't add anything else. And once equilibrium has been was reached, so at equilibrium, what's given is that there was only 0.44 moles of silver ions present. So at equilibrium, you're left with 0.44 moles per decimeter cube, because by default it's a 1 dm cube solution, so it's 0.44 mole per decimeter cube of silver ions were left in the solution. So what happened was, we need to find the equilibrium concentration of the other substances. So you can see the change. Initially you had 1 mole of silver ions, now you have 0.44 moles of silver ions, which means that 0.56 moles reacted, because they're missing. The only thing that could happen with them is that they reacted. And if you look at the equation, silver ions and Fe2 plus react in the ratio 1:1. So if 0.56 moles of silver ions reacted, which means the same amount of moles of Fe2 plus would also react. So the leftover Fe2 plus, initially there was 1 mole, now it's going to be, at equilibrium, it's going to be 0.44 mole per decimeter cube. So 0.56 moles of silver ions reacted. The same would be true for Fe2 plus as well. Now, if 1 reacts with 1, then it's going to produce 1 mole of silver and 1 mole of Fe3 plus. So if 0.56 moles reacted with 0.56 moles of Fe2 plus, then 0.56 moles of silver solid and Fe3 plus would be produced. So 0.56 moles of silver and 0.56 moles of Fe3 plus would be produced. Initially you had 0 moles, so at equilibrium, the moles of silver solid would be 0.56 moles, and Fe3 plus would also be 0.56 moles. So I've been able to figure out the equilibrium concentration. Remember, it's a 1 dm cube solution, so the concentration is by default 0.56 mole per decimeter cube. So I've been able to figure out the equilibrium concentrations. 0.44 mole per decimeter cube of Eg plus, Fe2 plus is the same concentration. And I'm going to write down an expression now for finding Kc. Kc is the concentration of products to reactants. So it's going to be the concentration. One thing that you need to remember is that solids have a concentration of 1. So silver solid is not going to be written in the expression, or if you want to write, then it's 1 would be written instead. Fe3 plus into the concentration of Fe3 plus, that's your other product, divided by the concentration of reactants, which in this case is the concentration of silver ions, into the concentration of Fe2 plus ions, and the values are going to be used are these values that are given over here. So it's going to be 0.56 divided by 0.44 into 0.44. Now the answer that I'm getting on my calculator for this is coming out to be 2.89. So the correct answer for this question is going to be option D. A lot of students make the mistake of adding the concentration of silver solids. Remember that solids have a concentration of 1. So in your expression, always whenever you have a solid, take the concentration as 1 or don't write that in the expression.